Hello everyone, this is Hating Tian. This video we are learning 4.2 properties of logarithms. We have learned logarithms in college algebra. We know that log and exponential function, they are inverses to each other. For example, if we review the exponential function, we have f of x is equal to 10 to the x power, and we are going to have my function look like this. And its inverse function, let's say the inverse of the f is g function, is going to be log x, and the base here is 10, which is the base of the exponential function. And for the log of the function, if the b is greater than 1, so b is the base. If base is greater than 1, I'm having increasing function. And if the b is less than 1, I mean in this form, log base b x, we're going to have a decreasing function. Okay, so for the b is a constant number which is greater than 0. b is not equal to 1. And the x value in the logarithmic function is always be greater than 0, positive number for the x. The y could be negative, but x is always positive. So for the base b, if the base b is 10, we call it common log. For example, log 5, that means log base 10, 5. And for the b is equal to e. So what is the e? E is a number is equal to 718 something. So if I have ln, which means the log base e, ln 5 is equal to log base e 5. Okay, let's review the properties of logarithmic expressions. If we have mn and b, they are greater than 0, b is not equal to 1. Inverse property says that log base b, so let's use highlighter, log base b to the x is equal to x for all x, and b to the power of log base bx is equal to x for all x is greater than 0. Let's make some examples. So the examples. For example, if I have log base 10 to the x, we know that the base here must be 10, but this is common log base 10. I can ignore that. Then we have x. We have x. And if I have log base 5 to the 4th, then we have 4. And some other examples, we have 10 to the log 7, for example. So is equal to 7. That's the property here. And if I have e to the ln to the 40, so ln 40, so is equal to 40. Okay, let's see next property, product rule. So if I have log base bn plus log base bn, then we can combine these two logs. They have the same base, log base bn times n. For example, if I have a log base 5 times, log base 5, 2 plus log base 5, 7. Then combine them together, I have log base 5, 2 times 7, which is log base 5, 14. Next property is quotient rule, quotient property. If I have two logs, they have the same base b, and connect them with a minus sign, then we are having log base bn divided by n. So for example, if I have log base 5, 20 minus log base 5, 4. So these two terms, they have the log base 5. And I can combine them together. They have log base 5 and 20 over 4. So do the math. We have log base 5, 5. Let me ask you, what is the power of this 5? 1. So by the first property, so come to here, we only have the power left, which is 1. So solution here is 1. So first we combine the two logs, then do the division between 20 and 4. Then we can simplify it a little bit more. So we have the power 1 left. Okay, let's move on to see next property, power rule. So if I have the p times log base b m, I can move the p to the power of the m. I can move the p to here. So we are having log base b m to the p's power. For example, 5 times log base, common log base 10, x is equal to log x to the fifth. And if I have the opposite, inverse way to move the power p to the front, for example, if I have ln 3 squared, I can move the squared, the 2 in front, 2 times ln 3. Okay, let's see, change the base rule. If I have log base ax, I can choose any random base b. b must be greater than 0. So it's not 1. So I can take the x, so bring the x and the a to the top and bottom. So we have log base b x divided by log base b a. So for example, if I have log base 5, 7, I can have log base ln 7 divided by ln 5. So we separate the 7 and 5, move the 7 to the top and move the 5 to the bottom. And both of them, they need to take another log base b. And this log base b, I chose the ln, which is log base e, natural log base e. Okay, why we are doing this? Because the calculator will not give me log base 5, 7, but it will give us the ln. So I can click ln 7 divided by ln 5. I can evaluate my number. Okay, evaluate the following expressions. Let's use the properties we reviewed to simplify the expression. So first we have log base 2. 2 to the negative 13 is negative 13. Next one, ln e to the square root of 2. So the base of the ln is e. So we have square root of 2. Next one, e to the ln 8. 8. Next one, we have two terms. We can combine the two terms. So log base 6, they have the same base, 6. So we can multiply the 9 and the 4 together. Log base 6, 36. Can you simplify a little bit more? Yes, because the 36 is equal to 6 squared. So this part, they can be simplified. Solution is the power 2. Next one, we have 5 to the power log base 5, 6 plus log base 5, 7. When I see this question, I focused on my power. The power, these two terms, they have the same base, which is log base 5. I can combine the two logs. Log base 5, 6 times 7. So we have 5 to the log base 5. Okay. Log base 5, 42. So the solution is 42. Okay, let's see next example. Is this a rule we have learned? I don't think so, because the rule has a rule. We have two log and they have the same base. I can do the multiplication between them. For example, log base 2n plus log base 2n. They have the same log base 2. We have log base 2 m times n. But now we have the multiplication between two logs. We don't have this rule. So let's think of some other methods. How to simplify it. So if I'm looking at my second log, is log base 6, 8. Can I use the change the base rule to change the base? Let's try. I can separate the 8 and the 6. So move the 8 to the top, move the 6 to the bottom, and take what log? I will take the log base 2 because I want them to have the same base log 2. So the bottom is log base 2. And then you see log base 2, 6, log base 2, 6. They are one top, one bottom. They are cancelled. Solution is log base 2, 8. And then do something for the log base 2, 8. So 8 is equals 2 cubed. Then the solution is 3. So this question is a little bit difficult. First, this is not a rule we have learned. For example, the product rule. And how to simplify the expression. I can convert all of the expression to have the same base, log base 2. And then we do the cancellation. Okay, I will ask you to try this. You can pause the video and try these 7 questions. So if you finish all of the 7 questions, you can look at the screen and find your solution. 25, and this one is -3, and this one is 12. And this one, I want to combine 2 log base 8 together. We have log base 8. 16 divided by 2 is 8. Now we have 1. And next one we have, so simplify the power. So base is 4. And raise it to the log base 4. Do the multiplication, 20. And then the solution is 20. Next one. Okay, convert them to have the same base. Maybe we can try to convert this one to be the same base, log base 3. So keep the first factor, log base 3 times 8, multiply by log base 3, 27, divided by log base 3, 8. Yes, they cancelled. We have log base 3, and then 27. 27 is 3 cubed. So we have log base 3, 3 cubed, which is 3. Okay, number 7 is the most challenging question. So this question, maybe the previous example will not help this one. This one, we have the base e, and now this base is not e. This base is e squared. What should I do? We can assume that, so we can say, let the power log base e squared 16 is equal to a. Then later we just want to find what is the e to the a's power if we can find the a's value. Okay, so let's rewrite the log form to the exponential form. So what is the base of the log? E to the squared. Converted to the exponential form, we have e squared then to the a's power is equal to 16. And then we have we need to multiply the a and 2. We have e to the 2a is equal to 16. So 2 means squared. Can you rewrite the 16 to be squared? Yes. So e to the 2a is equal to, we can do this. We can put the a here and raise the 2 outside, and then convert the 16 to be 4 squared. Now you see both of the side, they have the squared. Some of you say, you just swap these two. Yes, you can switch these two. So we have e to the a's power is equal to 4. We're very close to the solution. And we don't have to do anything because I'm looking for e to the a's power. And from the steps, I found the e to the a's power, which is 4. So we're done. We don't need to do anything. So we found the e to the a's power. Okay, let's see next one. Use the property of logs to expand the expression and simplify. So let's simplify the expression. Make sure you have no power in the log parentheses. So first I see we have the top and bottom in the log base 5. So we can separate the top and bottom by using the quotient rule, the opposite of the quotient rule. So we are having log base 5. The top is cube root of x squared plus 1 minus log base 5 x squared minus 1. And then we see there is root 3. What is the meaning of root 3? That means the power is 1 over 3, 1/3. X squared plus 1 to the 1/3 minus log base 5 times x squared minus 1. So my second term cannot be simplified. So we can move the 3 to the front by the power rule. So 1/3 times log base 5 x squared plus 1, then minus log base 5 x squared minus 1. Nothing can be simplified because here they are addition. If we have multiplication, I can separate two logs. But here is addition or subtraction, so nothing can be simplified. Okay, so let's see next part. For example, if the question says, did you factor your parentheses completely? So first one I cannot factor, but the second parentheses is conjugate formula. So I still need to simplify even more or expand even more. So 1/3 times log base 5 x squared plus 1 minus, in the parentheses we're having a plus b times a minus b, which is x plus 1 times x minus 1. Oh, this one can be simplified even more. So we're going to have 1/3 times log base 5 x squared plus 1, and then minus log base 5. So let's use the brackets because we need to separate my second term, and we need to use the bracket first. Log base 5 x plus 1, and then plus log base 5 times x minus 1 brackets. If I want to clear the brackets, we have 1/3 log base 5 x squared plus 1 minus log base 5 times x plus 1 minus log base 5 x minus 1. If we don't have a brackets, we're making mistake. Maybe we don't change the sign here. We should distribute the negative 1 to the brackets. Now, yes, nothing can be simplified. Okay, let's move on. So this part is so important because if I'm so careless here, for example, if I'm so careless, I forgot to factor it, I won't get full credit. Okay, let's see next one. Let's be very careful when we do the simplification. First, let's see. In the big parentheses, can you do some simplification, or can you combine some terms? Yes, let's see. The top we have 5 x squared, and so another factor is square root of 1 minus x. I can convert the square root to be the power 1/2. And the denominator is 4 times x minus 1 squared. But we know that if we have x minus 1 squared, that also equals 1 minus x squared. So there's nothing different. If I have a minus b squared is equal to b minus a squared, because the squared, and I can switch the position of these two, or switch the a and b and keep the minus sign between them. So this one only fit for the even power. Okay, now I identified that these two, they are the same base. I can combine them together first. So we have ln 5x squared divided by 4, and then multiply by 1 minus x to the 1/2 minus power 2. And then we have ln 5x squared multiplied by 1 minus x to the negative 3/2 divided by 4. So next step, let's move it here. We can separate my top and bottom. The top is 5x squared multiplied by 1 minus x to the negative 3/2 minus ln 4. And then we have multiplication here. So how many multiplications? So we have 5 times x squared times x minus x, 1 minus x to the negative 3/2. So I can separate to 3 terms. We have ln 5 plus ln x squared plus ln x 1 minus x to the negative 3/2 and minus ln 4. 4 is equal to 2 squared. So continue to do the simplification. ln 5, use the power rule, move the 2 in. Okay, move the 2 in front. Okay, let's see, where is it? That's really bad. Okay. Let's see. Write them really quick. ln, combine the base x minus 1 or 1 minus x together. We're going to have 5x squared times 1 minus x to the negative 3/2. All divided by 4, and then separate to the top and bottom. ln 5x squared times 1 minus x to the negative 3/2. Then minus ln 4 is equal to ln 5 plus ln x squared plus ln 1 minus x to the negative 3/2. And then minus ln 2 squared. ln 5 plus 2 ln x plus negative 3/2. I can move the power in front. ln 1 minus x minus 2 ln 2. So nothing can be simplified. You see, nobody has the power. So nobody has the power. So we don't have to use the power rule, continue to do the simplification. I expand my expression completely. Okay, some of you say, can I combine these two? Yes, you can combine them. You can say ln 5 plus 2 ln x minus 3/2. ln 1 minus x minus 2 ln 2. All right, let's see next example. Okay, this example, we have the power 3. So I don't have to separate the top and bottom first because I can move the 3 outside first. So we have 3 times ln 2x plus 1 over 3x minus 5. Separate the top and bottom. We're having ln 2x plus 1 minus ln 3x minus 5. We can use brackets. And then we can distribute the 3. We have 3 times ln 2x plus 1 minus 3 times ln 3x minus 5. Okay, let's see. You try, expand the expression and simplify. So you should do the same method. First, I can separate the top and bottom. I have ln square root of 2x plus 1. And then minus ln x plus 5. So for the square root, it is 1/2. So I can move the 1/2 in front. ln 2x plus 1. And then, so let's make it smaller. So minus ln x plus 5. And then equals 1/2 times ln 2x plus 1 minus ln x plus 5. Okay, next one. So move the 4 in front. We have 4 times log base 6 times 216 over x cubed y. And then let's keep moving. So separate the top and bottom. We have log base 6, 216 minus log base 6x cubed y. And then keep the 4 outside. We have, so log base 6, and what is 216? 216 is 6 cubed minus, so use the parentheses, separate the x cubed and the y. We have log base 6 x cubed plus log base 6 y. And then we have 4 times 3 minus, we can clear the parentheses and move the 3 in front. Log base 6x minus log base 6y. We can distribute the 4. We have 12 minus 12 log base 6x minus 4 times log base 6y. So this is expression, the expanded expression. And next one, if you have time, you can pause the video and do the question yourself. So let's separate the top and bottom first. So log base 2, 4 times cube root of x squared, and then minus log base 2 y times root z. So let's separate the 4 and the cube root of x squared. Log base 2, 4 plus log base 2, rewrite the power to be x to the 2/3, because for the root, for example, root n and x to the m's power, so this means x to the m over n. So n is the root, m is the real power, so power is m, root is n. Okay, so next term is minus log base 2y, and then plus 1/2 log base 2z. We do the distribution. So log base 2, 4 is 2 squared plus 2/3 log base 2x minus log base 2y, and then minus 1/2 log base 2z. So we can simplify the first term. That's the only term I can simplify. 2 plus 3, 2/3. So 2/3 log base 2x minus log base 2y minus 1/2 z. Log base 2z. Okay, let's move on to see next 2 examples. These 2 examples is use a property to write expression as a single logarithm. That means we need to combine the several log terms to be one log. But when we combine the logs, for example, log base b, I have m plus log base b, n. You see, in front of each log here and here, I don't have any other constant number. So the constant number is 1. Then I can combine them, log base b, m times n. For example, if I have a 2 here, I need to, move the 2 to the power of the m. Then use the m squared times n. And for the division is the same. If here is subtraction, we do the division. Okay, let's see the next example. If I want to combine the 3 logs together, I cannot have a 2. So first step is move the 2 to the power of x plus 1. Minus log base 3, x minus 5, x plus 5. Minus log base 3, x minus 1. So I can combine first two terms together to have log base 3, x plus 1 squared times, this is minus, so divided by x plus 5. Then we do another subtraction. Minus log base 3, x minus 1. So this is subtraction, we do the division. So x plus 1 squared divided by x plus 5, then divided by x minus 1. We say divided by a number means multiplied by its reciprocal. It is log base 3, x plus 1 squared, all divided by x plus 5 times x minus 1, x plus 1. Okay, let's see next example. Next example, I'm combining three terms together. I need to get rid of the power, get rid of the term in the coefficient in front of each logarithmic form terms. Okay, so first let's raise the 3 to the power of the parentheses. We have ln 3x plus 1 cubed. And then minus, so I can keep a minus sign, only move the 2. You can also move the negative 2. It's up to you. So ln 2x minus 1 to the squared minus ln x to the 1/2. Now they have the same coefficient, which is 1. I can combine them. Combine first 2, we have ln. This is a subtraction, we do the division. 3x plus 1 cubed divided by 2x minus 1, then minus ln x to the 1/2. And then combine them together, we have ln 3x plus 1 cubed divided by 2x minus 1 multiplied by x to the 1/2. And x to the 1/2 is square root, so I can rewrite the denominator. Denominator is 2x plus minus 1 times square root of x. So that's the last question of 4.2.